All right, so today we are doing AP questions on differential equations. So hopefully by now you went on Google and you printed out this worksheet that I posted. There's a bunch of problems and they're all numbered 4, 5, 6, some repeating 5. But what you really want to take note is the year. All right, I'm going to be doing 1998 today, and I'm going to be doing 2002. So these are pretty difficult. I just want to warn you. So try to pay attention. If you're stuck, press pause and rewind it and see if you follow along. So the first one says, let f be a function with f of 1 equaling 4. You know that's a condition, so that we're going to be used if we ever go to solve a particular solution to find c, or we just might use it. But that's telling me there's a point on f that is 1, 4. Okay, so that's a point 1, 4. Such that for all points on the graph, they tell me all points on the graph of f, the slope is. So they're telling me the slope of f is given to me by this equation here. Well, if the slope is given to me, then what they're really saying is that's the derivative. dy dx is equal to 3x squared plus 1 over 2y. Now, in the first problem, part A, they say find the slope of the graph of f at the point where x equals 1, which seems pretty easy because they gave me the slope. But they're telling me when x equals 1, and we're looking at the slope, and we're seeing that, yes, we need to know what x is, but we also need to know what y is. Well, we already know what y is. We just have to remember that condition that was given to us, that when x was 1, f of 1 is equal to 4. So the point that the y value that goes with x equals 1 would be y equals 4. So in this problem, they're just testing you if you understand the vocabulary. The slope is given to us, and they want you to find it when x is equal to 1. You're able to identify the initial condition goes with that. And so all you do is plug in the 1 for x and the 4 for y. So you should end up with 1 squared is 1 times 3 is 3 plus 1 is 4 on top over 8. So your answer to part A was 1/2. Not so bad, right? Okay. B says, write the equation of a line tangent to the graph. I stop right there. I go, oh, okay. I'm writing the equation, of a tangent line. Well, you know that anytime you write the equation of a line, you're going to use y minus y1 equals m times x minus x1, where you need to know a point and a slope. And we want to know the tangent line, write the equation of a tangent line of f. Well, I know a point on f. The point is 1, 4. So that's my point. That part's already found. Now the slope, well, they gave me the slope, and in part A, guess what? They asked me what's the slope at 1, and that's the point I'm going to use. So I now know m, when x is 1 and my y is 4, my slope is 1/2. So it's as easy as that. 1 minus 4 is equal to 1/2 x minus 1. And you can leave your answer like this. Sometimes I've seen answers given as y equals 1/2 x minus 1 plus 4, okay? But I would just leave it like so, right? But I didn't finish that question, okay? And I know the question is probably hard for you to read, so you should hopefully have that printed out. It's asking you to write the equation of the tangent line and use it to approximate f of 1.2. Well, we know this is the x value, so they're basically telling me to take this equation and plug in 1.2 for x. So here I go. I'm going y minus 4 is equal to 1/2 1.2 minus 1. And parentheses first, please don't distribute. 1.2 minus 1 is just 0.2, and then 1/2 of 0.2 is 0.1. And you add that 4 over, and we get that y is equal to 4.1. Done. Okay, so that was part B. That was also a nice question. Okay, where it gets a little difficult, C. Find f of x. So they're asking me to find f of x. And now remember where we started. We started being given a slope. So f prime, f double prime, I'm at my slope. I need to get to f. That tells me I need to integrate. Okay, and when we have to integrate with that slope, we're dealing with the separation of variable situation. So here they're saying, find f of x by solving the separable differential equation. They're telling you you're able to separate those variables. So here we go. dy dx is equal to 3x squared plus 1 over 2y. And they tell me I have my initial condition. That's even nice of them to repeat that. They really didn't have to. You would have to know to just go back and use that information. But anyway, so I want to integrate this. By now, we should all know that we cannot integrate when we have two variables on the same side, okay? You cannot have two variables of integration with the same integral sign. So we need to move it. So what I've been doing is I multiply by dx on this side, and I get that dy is equal to 3x squared plus 1 over 2y dx. And what this is saying, and I've said this numerous times on our videos now, that on this side where you see dx, that's where only the x variables can go. So therefore, I need to move y. So now you could move 1 over y, or you could move 2y over. I'm going to move that both over. I'm going to 1 over 2y, and 1 over 2y is going to come on this side. I got dy is equal to, oops, that's not what I needed to do. That was a little mistake. I need to multiply this by 2y, and I need to multiply this side by 2y. So I get that crosses out, and I'm left with 3x squared plus 1 dx and 2y dy. So we're here. Now we're ready to integrate. So I'm just going to rewrite that on another page. So we got 2y dy is equal to the integral of 3x squared plus 1 dx. Okay? And so now when we integrate, we just do basic integration. This becomes, you add an exponent, so you get y squared over 2 plus c is equal to 3x cubed over 3 plus 1x plus c. Okay, and so I just integrated. Those integral signs go away. I move the c over, and we know that here I do not cancel the c, I just get a new c. But what I am going to do is I'm going to cancel that 2 with divide that 2 reduces to 1, and the 3's cross out. So that reduces to x cubed plus 1x plus c. It's just a different c. Okay, so I'm here. And I know that there's a particular solution. They gave me the initial condition, f of 1 is equal to 4. So at this point, even though y is not by itself, I have 1c. So I'm ready, I'm comfortable to go ahead and solve for c. I plug in 4 for y and 1 for x. And I get that 16 is equal to 1 plus 1 plus c. 16 is equal to 2 plus c. I minus the 2 over, and I get that c is equal to 14. So I'm happy. Now at this point, I go back to what I call this piece here was my general solution with that plus c at the end. And I plug in the 14. I get y squared is equal to x cubed plus 1x plus 14. And now I just want to solve for y as they asked me to, and rename it f of x after we're done. And I square root. Now I know that a lot of you are saying it's plus or minus, and you're right. However, the initial condition tells me what I'm going to pick here. My initial condition said that my y value is positive. So when I take the square root, we know we have some sort of positive value, and we don't want it to negate it. So therefore, we're going to cancel out that negative, and the equation is f of x is equal to the positive square root of x cubed plus 1x plus 14. All right? And then last but not least, D is asking us, use your solution from part C to find f of 1.2. In part B, the student just used the tangent line to estimate it. Now we're going to actually find it. So we just plug in 1.2 cubed plus 1 times 1.2 plus 14, and then you get f 1.2 is equal to the square root. You could just put that into your calculator. It comes out to be something along the lines of 16.928, which then f of 1.2 is equal to 4.114. Remember those 3 decimals, all right? And that's it. I'm going to end this video because I will run out of time to do the next problem, so you'll have to run the next video to see the example of 2002. Now again, I expect that you might have to watch this twice and then try it on your own. And you'll see some of the practice problems are a little bit difficult, but again, I'm holding a Google Meet every week. So try to come. I had a couple of kids come last week and I think it really helped. I won't be repeating questions that I put on the video, but I would be repeating any homework questions that maybe the solution keys didn't make sense to you. Okay, so stop at this point and now look at the next problem, and I'm going to video that one too.